Thank you, Pete. Thanks so much for having me here in Singapore. It's very exciting. It's actually my second visit here. Beautiful city. All right, so I think we answered the most important question. Who knows Presto? So I will just skip through half of my slides and get to the gist, right? But the way we think about Presto is maybe a little bit more unique. Many people who use Presto, they just query data either in HDFS or S3 or some other object store. But in reality, Presto is actually capable of running queries across many data sources at the same time. And we see increasingly more complex environments among our customers where the data is not in one place, unfortunately, right? It would be very easy to have all data in HDFS or S3 or other object store like Azure Blob Storage, for example, right? But it's not the case. Most of the enterprise have data spread out across many databases, many storage engines, NoSQL engines, and to get insights from all of them real time, whenever they want, they need SQL that can execute statements across many of the data sources at the same time. So it's more complex than that. The list of data sources you can access with Presto is growing basically every month. There are new connectors. So some of the most recently added by the community are Apache Kudu and Elasticsearch. And as you can see, the list is pretty extensive already. And for users, they actually leverage anything. They can do, leverage BI tools. They can leverage SQL editors. They can leverage notebooks. Power BI, very popular among Microsoft users. So it's pretty much anything, as long as you can speak SQL. A brief recap of Presto history. Some of you may know it was born at Facebook about 7 years ago. They first ran into this issue with lots of different data sources, lots of data, obviously. At that time, it was a petabyte. Now it's exabyte, right? You cannot run effectively that SQL using commercial solutions. It's just impossible to do it in a cost-effective manner. So they wrote Presto as a successor to Hive. Hive was already there. It was great. It was handling scale. Just wasn't interactive and wasn't able to access many data sources at the same time. So now they open source that solution. My team at that point was basically we're running a commercial SQL-on-Hadoop solution. Our company got acquired by Teradata, which is very, very well known in data warehousing. Actually, they hit 40 years recently. I spent 3 years there. In that time, my team got involved in open source project Presto. Till date, we contributed about half of the code to the project. We made many, many releases along with engineers from Facebook. And then quite recently, we actually left Teradata and formed another startup because we're seeing so much potential for Presto, both in the cloud and in on-premise enterprise environments, that we decided to do it again as a startup. And then quite recently, some of the key engineers, founders of the Presto project that used to be at Facebook, they actually left Facebook and they just started independent software foundation to make Presto really independent of any organization and make it more accessible to the community. So that's how the Presto Software Foundation was started earlier this year. All right, so many of you use Presto, and you may actually see your company logos on this slide. If you don't see that, let me know. We can add that into this list. Presto is used everywhere, really, in many different industries, both cloud, on-premise, virtual environments, all over the place. Some of the companies here, you may be local, right? So Grab, for example, and a few others. It's just amazing how quickly this adoption happened. And what's fascinating was, a few years ago, when we started contributing to Presto, that community was maybe a handful of companies. Now it's just growing really fast. And I think the cloud is really the driver here. So lots of those users are in the cloud, AWS, but also Azure, and most recently, also Google Cloud. So I always want to review how people push Presto to their limits, right? As you can see, some of the biggest organizations in the world running big data, they're approaching a scale of thousands of nodes with Presto. Single node clusters are 900 to 1,000 nodes. Uber, Twitter, Facebook, obviously, they're running huge environments. There's almost 50% split of on-premise deployments versus cloud deployments. Some of those users are making migrations from big on-premise clusters to the cloud, like Twitter, for example. A big on-prem traditional customer moving now to Google Cloud. And many other organizations are making those bets. What's fascinating about Presto, it can run in both cloud and on-premise. It can also be hybrid, right? You may have data sources located in one place and run your compute somewhere else. Because of separation of compute and storage, that's very easy to achieve. It's pretty amazing setup. So let me know if you think you have bigger data or more nodes, those guys. I'll be happy to update my stats as well. All right, I think it's crucial to understand why Presto is gaining popularity. Like, what happened? What's unique about Presto that is gaining this adoption right now? I think there are several factors to this. First, obviously, it's a community-driven open source project. It's used by large organizations. They contribute back to this. They test this at scale. They contribute patches and features. There's no one vendor company that's driving adoption of this, which is really healthy for the community. The second thing, there's never something like enough performance for your SQL engine. Your data is growing every day, right? You'll be running more complex analysis. So having something that's proven at scale and is fast is just super beneficial. So that's a big driver as well. The third one, which I touched on, separation of compute and storage, right? Up until like maybe 5 years ago, you'll be running your big Hive jobs on your big Hadoop clusters. You would be collocating your compute with storage, right? Even though the software was separate, it was running on the same machine. It was leveraging locality. The assumption was that the network is slow, storage is slow. You need to bring computation to the data. And look now, right? Everyone is actually separating this. Is moving data into object storage in a cloud. That's abstraction. Like, we are not actually managing those machines anymore, right? We just store very cost efficiently lots of data, and now we just want to spin up compute machines, whether those instances on Azure, Google, or AWS, or on-premise, maybe Kubernetes or VM clusters. They never actually have storage on them. Like, they just do compute, right? And Presto, because it was just designed for that approach without maybe that was a conscious decision, but maybe if the founders of the project didn't fully realize that. But now it's a big advantage, and Presto is just right fit for the new cloud environment model, whether that's public cloud or private cloud. It saves you from doing a lot of expensive ETL from your data sources back to a big data warehouse or a big data lake. You can actually query your Oracle or SQL Server or IBM DB2. You can query all of them right now and join with the data in your Hadoop or cloud without moving the data physically through the ETL process that you have to define weeks in advance. It's a very powerful paradigm. And then finally, no vendor lock-in. So what I mean by this, you're not tied to your Hadoop distribution to ship you the latest version of Hive, Spark, or Impala, or what have you. You're not tied to a storage vendor anymore, because you can move your data from one storage engine to the other, and Presto will be still able to query that. So it gives you freedom to architect your data platform. And then you're not tied to any particular cloud vendor because, as we know, Presto runs in every single cloud and also on-premise, right? That helps you a lot with designing architecture that will survive probably years of transformations and innovation in other in another sort of storage or compute frameworks. So obviously, Presto is super fast ANSI SQL. Beyond ANSI SQL, you can leverage a ton of different SQL functions. Some of the things I'd like to highlight is you can run very complex regular expressions. That's super helpful to analyze log data. You don't need to you don't need to put your log data into a specialized logging analysis framework. You can actually run SQL leveraging those functions. You can simplify your SQL, especially complex transformations with Lambda functions and expressions to save you writing super complex nested queries. And you can also do really fancy geospatial analytics, which is something that was first contributed by Uber, and now recently it's probably leveraged by every single ride-sharing companies in the world, plus a lot of food delivery companies. They just want to do analytics with the geospatial information in mind. So I'm listing some of the examples here. We probably won't have time to go over them right now. But I think it's super powerful that SQL is still the answer for many of the complex analytics. Probably not as complex as my previous colleague was talking about, but there's a lot you can do with SQL still. All right, so beyond that, like Presto is open source project. There's a tendency to use open source everywhere, right? So some of the popular movement we see is around BI tools like Reader, Superset, Jupyter Notebook are really gaining popularity among SQL users as well. But you can still use traditional JDBC or DBC drivers for your Tableau, ClickView, Power BI, and also language bindings and extensions to make Presto more powerful. You can contribute your own custom UDFs and aggregate functions, and also you can actually build your own connectors, right? If there's no existing connector for your data platform, you can actually build your own or hire someone to build. There's a Java API you can follow to build a new connector. And we see that actually happening. So just in the last couple of years, there's a bunch of startups and companies building new storage engines that are specialized for unique types of analytics. All of those people are picking Presto as one of the leading SQL engines to integrate with. So starting with Databricks, they exposed an API to allow to query their data lake, which is sort of, you can think of this as an optimized Parquet-based table format that's working great in a cloud. There's Pulsar, which is Apache project for streaming analytics. Iceberg is another cloud-oriented storage engine for large tables. Apache Kudu, that's coming from Uber. And two things from TileDB and UgetByDB. Those are startups building specialized storage engines. And there's also internal projects like at Grab. They built a SQL access for a database storing their metrics with, they call it TellariaDB. You can read more about this as well. So it's a pretty powerful mechanism. So just a very quick introduction about me and my company. So I mentioned we are involved in the project for over 4 years. We've done lots of contributions to Presto. We offer a freely available distribution of Presto. You can call it, we might be a Cloudera for Presto or something like this. You can grab it for free and run anywhere. We support customers on the premises, but also in the cloud. Most recently, we introduced a Kubernetes integration that allows Presto to run in Azure, in Google Cloud, and in AWS, and also on-premise, right? Kubernetes is everywhere and allows you to standardize on one deployment model with auto-scaling, HA, like making things very flexible and compatible with all the environments. Some of the things we contributed back to the community as an open source, we've done lots of extensions to ANSI SQL so to make really compatible with BI tools and complex analytics. We've done lots of performance improvements, also security integrations. Like in the early days, Presto was great at creating massive data, but it wasn't compatible with Kerberos, LDAP, things like Ranger, Sentry, and so on. So we fixed that gap, and then worked on spill to disk and cost-based optimizer. And cost-based optimizer is something that I would like to focus really in this talk to show how applying some of the performance optimizations from database industries for decades are sort of improving open source today and improving cost efficiency of running those environments. So Presto itself was built for performance from the beginning, right? That was the motivation why Presto was born as a successor to Hive at Facebook. Super fast columnar execution, vectorized operations, efficient structures internally, pipeline execution, really good, very good architecture from the beginning, right? But was lacking cost-based optimizers. So my team, just going back to maybe 8 years ago, we sort of started building those technologies in my previous startup, and then when we started contributing to Presto 4 years ago, our goal was to always introduce those to Presto and make that impact to the open source community. So we've embarked on this work. We decided to do very basic optimizations first and see how far they can carry us. So we leverage statistics that you already collect in your Hive MetaStore for your Hadoop environment or for your cloud environment. Hive MetaStore is the standard for metadata in the big data environment and a data lake. So we leverage those to do three things really: join reordering, join type selection, and also this decision which join is on the left or versus right side. And there's a big blog posts, like probably several of them, discussing the details, but in a nutshell, we leverage the basic stats from MetaStore, like number of rows, number of distinct values in a column, and so on. We leverage that to estimate how expensive it is to run analytics, taking into account CPU, memory, and network I/O. And we are doing those basic optimizations by switching, typically in your query, really, like you have many joins, right? There's no way you know the perfect join order yourself. There's no way you know which one of them should be distributed versus broadcasted. But with stats, Presto is able to make automatically decision to do that very well. So we'll be doing the join selection. We'll be doing the decision among two tables, which one should we be on the inner side versus outer side. Doing this properly saves CPU time, memory, and just improves performance in general. And then for more complex SQL statements where you maybe filter data, you have where conditions that will change the game, right? You cannot just look at the table size anymore. You have to look at how selective filters are, how much you're going to reduce the effective number of rows. You'll be looking at the join cardinality, trying to estimate how many rows will be produced by a join. All of this is very complex algorithm, and will basically produce something that Presto believes is sort of the optimal join order, given the statistics and things we have estimated. We handle left deep join trees and bushy joins, so really exploring all possibilities to really perform very well. And just to give you a sense where this leads us, right? So Presto before Optimizer was already very fast, but was just breaking for the complex queries. We leveraged TPC DS benchmark, which is pretty common in the industry to measure sort of how SQL engine is running effectively. And we ran all the 99 queries. Among those, I'm just highlighting maybe 20 of them that are just benefiting greatly from optimizer, right? So just the simple fact that Presto is choosing the right join order or the join strategy it will lead you to speed ups, from like 5x, 10x to even 20x, right? And if you think about this is now a deal breaker, right? Because now you can run more queries effectively. You can make your users happy because they just get answers quickly, and you're able to push Presto to do bigger jobs. And if you take the same thing and run it in the cloud, which is the environment you're probably mostly working with, that's now translating directly into savings, right? Because you can run fewer machines in the cloud, pay less for compute, or just take more workload and be able to deliver more business results to your users, right? So just a simple benchmark we ran with unoptimized Presto on EMR versus the one with optimizer. First of all, half of the queries that were failing before are now going to execute successfully, which was a big deal. And the second thing, among those that were successful, we are seeing speed up. For example, here you can see half of the queries are 5 to 10x faster, right? And some of them are more than 10x faster, and it's just like really improving user experience. So just most recently, our team delivered all of that probably around like April last year. Contributed back to the community over the next several months, but we are not stopping there, right? We want to push this even further. What makes Presto unique is that now we can leverage Presto for running complex analytics across many different data sources and leverage optimizer to go beyond just big data stored in Hadoop platform or in a cloud, right? We can enable DBMS federation, right? So if you are joining queries against big data and your traditional relational databases, now Optimizer is taking into account stats from both environments and coming up with the plan that's optimal across those two different data sources. We can leverage additional catalogs. We can actually employ Presto stats directly rather than leveraging Hive for that, and just did overall optimizations in selectivity and cardinality estimations. I would say we have still plenty of work to do to improve it. First of all, we discover various limitations in statistics in the Hive meta store. We would like to fix how estimates are done for partitions. Most of your workloads are only picking several partitions from your big data source. Today, Hive is very primitive in the way it supports aggregate statistics, so we would like to improve that. We would like to introduce statistics for more connectors to provide you even better experience in those SQL-on-Anything environments, and tolerate missing and incomplete stats. It's a big deal. Like in some of those environments, you may not have stats for all your tables or partitions, right? We want to improve that by applying some heuristics to allow you to leverage whatever you have already collected and then making some reasonable guesses about the situations that are not fully analyzed. And then we can go further in terms of estimating more operators for various database operations. We can adjust cost model to your hardware. So we quickly realized that some of the tuning options are really unique to the environments you'll be running, right? So your on-premise hardware may have different performance characteristics versus your cloud environment, right? For example, in the cloud, often you may have less CPU cores, but your your network may be slower. Your disk I/O and network I/O is a bit more limited versus your highly optimized on-premise environments. So there might be some different approaches there. And also adaptive optimizations. It's especially with the cloud, your cluster may actually expand and shrink based on how much analytics you throw at this. Knowing how those variables change may improve your query performance or actually decrease the query performance. So making adaptive optimizations while the query is running, especially for larger jobs, is really important. And then there's a whole concept of trades where you may track interesting properties of your query plan that may not directly be expressible as a less expensive plan, but it's very valuable to know your data is sorted in a certain stage of your operation before you push to the further stage. And we also want to involve connectors in optimization. So far, Presto has a global optimizer, and it treats every single data source and connector as a relatively dumb data store. In a sense, it will be providing rows and columns. It cannot do aggregations, joins, or anything like that. So earlier this year at Strata Data Conference in San Francisco, Martin and I were talking about how we can sort of figure out what to push down to your data sources that are more capable than just object store or HDFS. So we'll be exploring this and probably coming up with some designs later this year. So that's about it. I always encourage people to run their own benchmarks on their data and see how Presto performs. But if you just want to look up what other people did in the past, there's a bunch of links. Obviously, those slides will be shared, so you can click on them and see what people are doing, how they're finding Redshift not being super fast anymore and definitely less cost effective. And they are comparing commercial solutions to open source solutions, Spark and other things. So definitely go ahead and take a look. Yeah, that's about it. I highly encourage you to come read our blog and sign up for a newsletter to sort of be more immersed in the Presto community, contribute to the project. Talk to me right now over the coffee break, office hours, if you have any use cases and just want to learn more about Presto. We have a bunch of contributors to the project and committers, and would like to encourage you to join the community as well. Thanks so much.
Any questions for Kamil? Here, I got it. Anyone, questions? Yep.
So I'd like to ask, what are common deployment patterns that you see for Presto? Like, for example, it's more common for companies to kind of have one super big cluster that is shared among many users, or, so what are the patterns there, and in what use case? Thank you.
Yeah, absolutely. So the question is about what's the deployment strategy, big cluster versus a number of smaller clusters. I think it depends, really. Especially with the cloud or cloud-like deployments, say Kubernetes, we're seeing more push towards smaller clusters. Some of them will be temporarily auto-scaling to a big cluster. Some of them will be shrinking back. Some of them will be shut down. If you have cloud or cloud-like environment, I would be going, I'll be advising you to try dynamic approach. Group users definitely do not run a single cluster per user, right? But if you have a department that's doing some financial analysis or ad analysis, like group them into several clusters and manage their workload profile that way. And if you have a bunch of users that are using fast BI analytics, put them aside from those running big discovery ad hoc jobs that may be just more resource intense and they have different SLA profile. And you just don't want to mix the two because it will be poor experience for both. Yeah.
Someone else? All right, so Kamil will be in office hours in half an hour after our break. So thank you, Kamil.